Hello everyone, I'm Licha Fongpong and today I will demonstrate my project Anomaly detection in industry control system data. First of all, let me browse the household one and smart mile data, and we chose the first one. And let me use the daily analysis. And in here we can see the household one smart mile powers and voltage 1, voltage 2 versus 3, and in the below bar we can see the hub power. In this data we have 7 hub power. And keep going, we can use the monthly analysis and we keep on choosing the household one and we chose the pub data 1 and pub data 4. And because we have to dealing the bunch of the data, because this is the monthly analysis, so we have to pay a lot of time to analyze this. Of course, this have to depend different machine have different time range. And monthly analysis also has smart mile power, voltage 1, voltage 2, and voltage 3. And we have more detail pub data. As before, we are choosing pub data 1 and 4. We can only see these two only. Key on is the noise scale, and we can choose the parameter by ourselves. And here we will choose the 5%. We will using this on the daily analysis, and after the analysis, we will show the little different data of the original data. And when we extend the noise detail, we can see the difference with the original data. It basically is extended by the noising and setting the parameter of the 5%. And key on, I will talk about the anomaly injection function, and now I will set the time from 1 to 20k second to end. First of all, we show the correlative 0, and here we can see the correlative 0. It basically turn the original data to the 0 in 1 to 20k second. And keep on, we are talking about the gradual script, and this basically is keeping increasing of the original data and keep increasing and increasing. Ultimately, it's different with the original data. And keep on, we talk about the transient spike. This is a simple injection, and basically it's turning the original data to super largest power. Keep on, we will talk about the periodic noise, and this is a little bit complicated injection. And basically say this injection giving some of the distortion of the original data. The last one is camouflage fluctuation, and this is also a complicated injection, just like as some of the Gaussian line in the original data. So we can see is totally different with the original data. And keep it on, we will talk about the multiple injection, and here have some of the preset I can using. It is include the file of the anomaly injection. You can see file of the anomaly in here, and we can choose the inject all of the anomalies. And after that, we can see all the anomaly is ingested into the one of the CSV files. And keep it on, we can go into the detection parts. Here have role-based and machine learning. And here we chose the single injection file of here. Now the first part is the role-based injection, but the in this single injection is not included. Detection need role-based, so we can skip this. Continue, we can get the machine learning part. This includes the isolation and LOF algorithm here. And here we can see very clearly realization detection of the machine learning. Keep it on, we can get the performance analyzer with the F1 score. And in here we can see the hypo algorithm. Isolation focus and LOF had get the very well score, basically over the 0.75. And keep it up, I will using the multiple injection to do this again. And first of all is role-based, and this is the detect very well of the two normal, the correlative 0 and transient spike. Here we have to wait some of the time of the machine learning, but the multiple injection two algorithm can detect the most difficult injection. Transient spike and correlative 0 is not easily detected, so we will give it to the role-based. In here we can see the most powerful algorithm is the mixed algorithm, and keeping on is isolation focus, and keeping is the LOF. And in the last week is the real-time simulator, and we can control the payback time with the panels. You can choose fast or slowly here, but the maximum speed is the 1000. And here is my demonstration, and thank you very much.